While teaching you SRTF algorithm in the last class, I forgot to tell you that a data structure that SRTF algorithm uses is minimum mean heap. Okay, mean heap. Here I will not explain you anything regarding this, because while teaching you data structure, things will be more clear to you what is mean heap, and then you will be able to understand why SRTF algorithm is uses this mean heap data structure. So just for the time being, just remember this point, that SRTF algorithm uses mean heap data structure. Okay, because you see this data structure has the property to select the minimum value. Okay, I will tell you detail while teaching you data structure. Okay, and now another important thing is that this SRTF algorithm is not actually it cannot be implemented practically. Even SJF algorithm cannot be implemented practically. Why? Because it's very difficult to predict the burst time before the starting of the process. You can't predict the burst time. It will be very difficult. You see, in SRTF algorithm or SJF algorithm, what's happening? Here, on the basis of burst time, we are allocating CPU to a process. Okay, because even after the execution of the process, we have burst time. We know the burst time and the base, and on that basis, the CPU is getting allocated to those processes. The process which has lower burst time, CPU will be allocated to that. But it's very difficult to predict the burst time before the execution of the process. So there are some methods from which you can predict the burst time. Okay, so there are some methods, but I will teach you only one, because that's more important. Okay, so we have burst time prediction technique. Okay, so it's of two types. One is static and the other is dynamic. So what's about static? Process type, process size. So how this process type is used to predict the burst time of a process? So here what happens, based on the type of the process, we predict what can be its burst time. Okay, suppose a process which is very fast. Okay, so we can predict, okay, it may have the burst time of 1 or 2 milliseconds, or based on it or based on the process of the same type which has ran previously. From there we can also guess the burst time. Okay, suppose there are two processes, P1 and P2. Both are of same type, but P1 has already ran previously and it took 2 milliseconds. So since both are of same type, so for P2 we can predict the burst time. Okay, P1 has the same type as P2 and P1 took 2 milliseconds, so definitely P2 may take 2 milliseconds. So it's about process type. And what about process size? Process size means what? Based on the size of the process, here we are predicting the burst time. It means what? If the processes have same size, suppose P1 and P2, both are suppose 2 kV. So if P1 ran earlier and it took 2 milliseconds, say, then since then on the while running P2, we will see that, okay, the process of same type and same size took 2 milliseconds, then definitely P2 will also take 2 milliseconds. Okay, so it's about static. Yeah. And now let's come to the dynamic part. The first one is simple averaging, and the second one is exponential, and the second one is exponential averaging. Averaging, or you can also tell it as aging. Okay, so this exponential averaging is important, so I will teach you this, but let me give an introduction of simple averaging. Here what happens that based on some processes which has ran previously, okay, and based on the burst time of all those processes, we can predict the burst time of the upcoming process. It means what? Suppose P1, P2, P3, P4. Among these processes, P3, P1, P2, P3, only 3 processes ran, and we will see the burst time of all these processes individually, and we will calculate the average, and we will predict that, okay, this average burst time may be the burst time of process P4. Okay, so it's not important. So let's come to exponential averaging. So it's very important. Okay, so let me, should I rub this? Okay. So what happens here? You see, here here we guess some burst time, and based on the previous burst time and our guessing, based on the previous burst time and our guessing, we are calculating the new burst time. You see how the formula, first write down the formula. It will be Tn plus 1 is equal to alpha into Tn plus 1 minus alpha into Tn. Okay, let's write here small t, and here it will be capital T. So here alpha is a scaling factor. Don't worry about the term. You don't have to know too much about this term. It is scaling factor. Its value will be given in the examinations. Okay. So here, what is this Tn? Tn is the actual burst time of the previous process. Okay. And Tn is our initial guess. Okay. So here, how this, how we here just let's analyze this formula. So it's better I should take one numerical example. After that, we shall analyze the formula. Okay. So first, write it down. Write down this formula. So I am roughing it. Here you see one question. The question is, we have T1 given is equal to 10, then alpha given 0.5, and previous burst times given as 8, then 7, then 4, then 16. Okay. So here you see this capital T1. What is this? It's our initial guess. It's our initial guess. And these are the actual burst time of previous four processes. So based on this, we will calculate the burst time. Okay. So just write it down clearly. And now the question is that we have to find out T5. It means what? We have to predict the burst time of process P5. Okay. Here the actual previous burst times of four processes are given. It's T1, it's T2, it's T3, it's T4. Okay. T1, T2, T3, T4. And based on this actual burst time of the previous four processes and also based on this initial guess, we have to guess the burst time of the fifth process. So you see how. Here you see T1 given. So let's calculate T2. T2 is equal to alpha, just see the formula. Here n is equal to 1. Okay. So 1 plus 1, T2. Here n is equal to 1. Okay. So T2 is equal to alpha into n is equal to 1, alpha into T1 plus 1 minus alpha into n is equal to 1, T1. Okay. Here then value of alpha given is 0.5. Okay, don't worry, it will be given in the examination. 0.5 into T1 into 8 plus 1 minus 0.5 into capital T1 means 10. So it will be, I am writing here, 4 plus 5 is equal to 9. Okay. So based on this initial guess, so now we have calculated T2. We have to calculate T5. So let's calculate T3 now. T3 will be same formula. Now alpha, now here n is equal to 2. Okay. Now alpha into T2 plus 1 minus alpha into capital T2. Here it will be 0.5 into T2. T2 is 7 plus 1 minus alpha. If you replace alpha with 0.5, then 1 minus 0.5, it will be 0.5 into capital T2. We have find out the value of capital T2 as 9. Then it will be 3.5 plus 4.5. 8. Now let's calculate T4. Here the value of small n is 3. Then alpha into T3 plus 1 minus alpha into capital T3. So it will be 0.5 into small t3. Small t3 is 4 plus 0.5 into capital T3 is here we have calculated it as 8. It will be 2 plus 4, 6. Now finally here comes T5. It will be alpha into T4 plus 1 minus alpha into capital T4. It means what? It will be 0.5 into what's the value of small t4? 16 plus 0.5 into what we have calculated the value of capital T4 as 6. It will be 8 plus 3, 11. So here we have predicted the burst time of process P5 is 11. Okay, are you getting it? So T5 is 11. That's the answer. So let's analyze some more. Okay, here you see why we have used this formula. Here you can see that there is a scaling factor alpha. Okay, suppose let's wait. From here you can analyze one thing, that is, if the scaling factor is 1, suppose here we have used the scaling factor of 0.5 because it was given in a question. But if the scaling factor is 1, that is, if alpha is equal to 1, then what will happen? Just substitute this value in the formula. What will happen? You see, it will become, should I rub this? Okay. You see here, if the value of alpha is 1, then what will happen? You know, it is a guess. No, it's not a guess. It's actual burst time, actual previous burst time, and this is a guess, initial guess. Okay. So you see, if alpha is equal to 1, then just substitute here. What you will get? Tn plus 1 is equal to alpha. In place of alpha, you just put 1. It will be 1 into Tn. 1 into Tn plus 1 minus 1 into capital Tn. So it will become Tn. Okay, here it will become 0. So Tn plus 1 is equal to Tn. It means what? If the scaling factor is 1, then what will happen? Then the burst time prediction will be just equal to the actual burst time of the previous process. Okay. So from here you can understand Tn plus 1, it is the burst time prediction of the next process is equal to Tn, and Tn is the actual burst time of the previous process. From here you can say that if alpha is equal to 1, then the burst time prediction of the new process is equal to the actual burst time of the previous process. From here we can guess the burst time. Okay. So although we have some techniques to predict the burst time, but still we can say that shortest remaining time first is not actually implementable. It's a hypothetical concept. Okay. So after this, I will teach you round robin scheduling algorithm, which is a bit difficult to understand, but if you focus carefully, then it will be very easy for you. Okay. Thank you.